Hey everybody, we're going to talk about 4.2 in your book. This is compound inequalities. Two inequalities joined by the words and or are called compound inequalities. Here's a couple of examples that you can see here. The solution set of a compound inequality formed by the word and is the intersection of the solution sets of the two inequalities. We use this symbol here. Looks like kind of like an N to represent intersection. I remember this because it looks like an N. The word intersection begins with that N sound, even though it is spelled I-N. So that is the intersection symbol. So here's a visual for and, also known as the intersection here. We got a Venn diagram here. You'll notice where A and B intersect. This is going to be A intersection B. A intersection B. Here's an example. Here we have two sets. So set A, x is an odd number greater than 0 but less than 9. So think about what that could be. You'll see it down here. Greater than 0 but less than 9. And it's an odd number. So that'd be 1, 3, 5, and 7. Greater than 0 but less than 9. And we have set B, which is 4, 5, 6, 7, and 8. We want to find A intersection B. So what shows up in both A and B? Does 1? No. Does 3? No. Does 5? Yes. 5 shows up in both. Does 7? Yes, it does. So 5 and 7 show up in both. So the intersection of set A and set B is 5 and 7. Here's another example. We're going to solve x plus 4 is greater than 0 and 4x greater than 0. So you solve both these just like we've done before, subtracting 4 on both sides, giving us x is greater than negative 4. On the right side here, 4x is greater than 0. We divide by 4 on both sides, we get x is greater than 0. So x is greater than negative 4 and x is greater than 0. So we graph both these independently. We're going to figure out where they both overlap. So here we have x is greater than negative 4, there. Here we have x is greater than 0, here. Notice the open circle. So what do these two share? Like, what do they have in common? Where do they intersect? You'll see that here in the red. The 0 has an open circle and everything to the right of that on the number line. It says here, as we see from the last number line, the solutions are all numbers greater than 0. So we can write this as x greater than 0. It doesn't always work out this way, but on this particular one it did. Let's solve another one here. 5x is greater than 0 and, again, and is showing up, so we know we're dealing with an intersection. What parts do they share? I should say, what values for x do they share? And 3x minus 4 less than or equal to negative 13. So we solve both these. We end up with x is greater than 0, and we end up with x is less than or equal to negative 3. So first, x is greater than 0. You'll see that here. Open circle at 0, shade to the right. X is less than or equal to negative 3. Closed circle at negative 3, shade to the left. So what do they have in common? What shared area do they have? They have nothing in common. So it's just a blank number line. There is no number that is greater than 0 and less than or equal to negative 3. So the answer is no solution here. That does happen sometimes. To solve a compound inequality written in compact form, such as this, 3 is less than 5 minus x is less than 9. We get x alone in the middle part. We must perform the same operations on all three parts of the inequality. So to get x alone, we're going to have to make it a positive x at some point. We're also going to have to get rid of that 5 there as well to isolate x. So here's what that looks like. You'll see we subtract 5 everywhere. 5 minus 5 is 0. I have to do that on the left side of the inequality, also on the right side of the inequality. So I'm left with negative 2 less than negative x less than 4. We divide everything by negative 1. So you'll see that here. Divide everything by negative 1. Remember, when you divide or multiply by a negative number in an inequality, on both sides of the inequality, or in this case, all three sections of the inequality, you do have to flip your sign. So you'll see the sign flip here. And we get 2 is greater than x is greater than negative 4. We can flip all this around. So negative 4 is less than x is less than 2. So this is the low end here at -4, and you'll see an open circle there at -4. This is the high end here at 2. You'll see an open circle at 2, and we shade everything in between. The solution set of a compound inequality formed by the word OR is known as the union of the solution sets of the two inequalities. We use the symbol, it looks like a U, that symbol right there, to denote union. So this is pretty easy to remember. U and union looks like a U. And the union is everything in set A and everything in set B. Make sure you don't count the part that is shared twice. So here's what we're talking about. If set A is x is an odd number greater than 0 but less than 9, and set B is 4, 5, 6, 7, 8, find A union B. So remember set A, this is the same from earlier, 1, 3, 5, and 7. Those are all the odd numbers greater than 0 but less than 9. So it's everything in set A and everything in set B. So that's 1, that's 3, that's 4. That's 5. Now notice 5 shows up in both sets, but we only write it down once. That's 6. That's 7, and again 7 shows up twice, but we only write it down once, and that is 8. So you don't repeat what shows up more than once. But everything in set A and everything in set B is included in the union. Think about this as a marriage. So when you get married, one person has a bunch of stuff. The other person has a bunch of stuff, and when you get married, the union, right, that's another word for marriage, the union, all the stuff is now shared. Also, the stuff that you have together, like so maybe you got a dog while you were dating, so the stuff you had individually, the stuff the other person had individually, and the stuff you got together, that is all brought into the union, right? It's all, legally, it's all everybody. So that's why when people get divorced, they chop everything up halfway. So union. Solve this with the OR in there. 6x minus 4 less than or equal to 12, or x plus 2 greater than or equal to 8. Again, you solve it just like we always have. We get x is less than or equal to 8/3, or x is greater than or equal to 6. So here you'll see x is less than or equal to 8/3. You can just estimate where 8/3 is. That is a closed circle because it is less than or equal to. 8/3 is included in your solution. And then x is greater than or equal to 6, so closed circle is 6. Shade everything greater than that. So OR. So it's going to be this solution and, well, I shouldn't say and, but it's going to be both of these combined. Both of these combined. And that looks like this. So there's your solution. So the solution you would say is x is less than or equal to 8/3, or x is greater than or equal to 6. Let's look at another one. Negative 2x minus 6 less than negative 2, or 8x less than 0. So again, you solve for x in both inequalities, and we get x is greater than negative 2, or x is less than 0. Shade each individual number line. Here you see x is greater than negative 2, shaded to the right, open circle at negative 2. Here you see x is less than 0, open circle at 0, shade to the left. You'll notice that all real numbers are included here, right? Everything less than 0, everything greater than negative 2. So this is everything, and you can see this in this number line here in red. So the solutions, you would say all real numbers for the solution set. Here are some practice problems. I want you to write them down. Pause the video now. Work these 3 practice problems now. Pause the video. All right, let's take a look at the answers here. There they are. 2 is greater than x, and x is greater than negative 8. You should have put that on a number line. You might have said x is less than 2. That's the same thing as well. 5 less than or equal to x. X is less than or equal to 9. X is greater than 7, or x is less than 1. I'm not including the number lines on purpose. I expect you to do those on your own. Bring them tomorrow to class. If I take this up for a grade, you'll be expected to have these solutions, the supporting work, and the number lines. Thank you.